Right, good morning, good afternoon, or even good evening to some of you, depending on where you are in the world. It's certainly evening with me here in Germany. Thank you for joining us for today's session on building a digital twin for sustainable resource management, sponsored today by GE Digital. First off, it would be great if you could, just in the chat, tell us who you are, where you are. It's always nice to get a feel for who's joining us and from where. And while you do that, get settled in, grab a coffee, whatever you need to do. There are a few bits of housekeeping just to start off with. This session is going to last just short of an hour. I'm going to introduce the topic and, of course, our expert panelists. And we'll be getting a lot of valuable insights from them, of course, but we're going to leave some time at the end for questions from the most important people in the room, and that is you, our audience. So please do post all your questions in the Q&A function. And please do it in the Q&A function, not in the chat. Just makes it easier for me to find them, and it's more likely that your question is going to get answered if they're easy to find. Once we publish the questions that are coming in, then you'll also have a chance to upvote them, and we will obviously use the popularity of the questions to prioritize which ones we answer first, and we'll get to as many as we can. But don't wait till the end. You can start putting your questions in all the way through the session. No need to wait till the end, so please do that. Right, and then with that, it's time to focus on the session, which is, as I said, building a digital twin for sustainable resource management. Sustainability regulation, customer demands are putting obviously a lot of pressure on manufacturers in particular to both report and continuously improve their resource management approach. And digital twins are becoming a crucial asset for tracking and reducing consumption to meet those kind of sustainability goals. And so what we're going to be doing in this panel is to discuss things like real-time monitoring, analysis, including process benchmarking, setting actionable goals in the context of the production workforce, and hopefully also sharing some real-world success stories about how resource use is being optimized using digital twin technology. And we're also going to look at some of the benefits that come out of that, of course. Reducing costs is one that makes everybody happy, usually, and improving industrial leaders' confidence in their decision-making. And that really, I think, is a very important part of the IIoT investment story overall, the ROI on those investments. And that doesn't matter whether you're talking about this or something else. That decision-making improvement is very key, I think. I'm delighted to say that we are joined by not just one or two, but three experts to help us go through some of these topics. And I'd like to introduce you to them to you rather now. First up, we have Ben Whiteman, who is Product Manager for Circularity and Sustainable Manufacturing at GE Digital. He has a background in supply chain and manufacturing, and he brings a visionary and grounded approach to software innovation in digital manufacturing space. And he's managed, analyzed, optimized manufacturing in food and beverage, for example, also consumer packaged goods. And he now works with GE's customer base across lots of different industries to help them meet their sustainability goals. He's very much a systems thinker, and he has a passion for architecting circular, regenerative, and equitable industrial processes to really drive value on both a local and global level. So thank you very much for joining us, Ben. Next, we have Cobus van Heerden, who is Senior Product Manager for Analytics and Machine Learning at GE Digital. He has 20 years of experience in developing and implementing industrial software globally. He specializes in helping industrial organizations realize transformational productivity gains. And how does he do that? By applying digital technology, advanced analytics, and machine learning. So thanks very much for joining us, Cobus, as well. And thirdly, we have Alan Hinchman, who is Chief Innovation Officer at Grey Matter, the industrial technology solution experts. Alan also has more than 20 years of experience managing technology and automation deployments across North America. He most recently served as the Chief Operating Officer of the Water Initiative, which is a team of global business executives and scientists who develop water systems to fit local conditions. So I'm hoping we're going to have a couple of water examples in here somewhere as well, because obviously water is very, very important as a resource for manufacturing. And in addition, he has a lot of experience in energy, oil and gas, commercial buildings offerings in this space. So welcome, Alan. Thanks for joining us as well. Also a very short notice, so we really appreciate that. And then just a couple of words about me. I'm Hamish Mackenzie, your moderator for this session. I've been running my executive consulting, coaching, and advisory business from here in Munich, Germany since 2006. I work with lots of B2B technology clients in Europe, America, Asia, helping them really set and execute on strategy, position their solutions in terms of customer outcomes rather than features and functions. I also work with CEOs and founders of startups, scale-ups, helping them spend a lot more time working on their business instead of in it. And of course, I also moderate lots of these kind of events, both online and live. If you'd like to know more about me and what I do, then please don't hesitate to connect with me on LinkedIn. I'm pretty sure I'm the only Hamish Mackenzie in Munich, so it shouldn't be too difficult to find me. One more quick reminder, get your questions into the Q&A function in the platform, and we'll look forward to answering those towards the end of the session. With all of that said, I think it's time we got stuck into the discussion. So I like to start off these things by setting some context. And obviously, we all realize sustainability is a key issue for businesses generally, and I think it's only likely to get more important. But manufacturing in particular, obviously, we also recognize perhaps that some of these sustainability goals are very, very hard to hit at a governmental level, country level, global level, and also right the way down to micro level individuals. And I actually quite fancy the idea of having a digital twin myself to help me work out, what contribution I can make to all of this. And maybe that's a discussion for another time. So if we go back to the planet manufacturing, as it were, and maybe I can start with you on this, Ben. Could you maybe talk us through what are some of the main challenges that manufacturers are facing in terms of making their operations more sustainable from a resource perspective?
Yes, thanks, Hamish, for that question. I think when we think about the main challenges in the manufacturing and industrial sector with respect to sustainability, some of these challenges are new and unfamiliar. Many of these challenges are common toward any transformation activity or any transformation initiative. I'd be remiss if I didn't say there's a new set of metrics that now are being used to assess performance for the organization. And so a new set of metrics requires the ability to measure and then manage those metrics. And so that requires, in some cases, new capabilities, in some cases, the extension of existing capabilities. But often one challenge I think that the push towards sustainable manufacturing presents is the data that's needed to feed those metrics is often either not being collected or difficult to collect. And so there's a renewed motivation for investing in the capabilities to collect, aggregate, manage, and then derive value from the data that's coming or that can be pulled from manufacturing operations. So I think the measurement of a new set of metrics is a key challenge. Mm-hmm. But again, many of these challenges are common challenges to any transformation initiative. Change management is a huge hurdle. So, bringing the organization on board and getting the kind of cross-functional buy-in, understanding how to cascade responsibilities to a multitude of business functions within an organization is a key hurdle that is true whether you are trying to make your organization more sustainable or whether you're trying to enact a digital transformation across your organization or other initiatives as well. So, I think the change management piece is key to acknowledge. And then, in every organization, silos exist. Organizations get very efficient within kind of their own silo at performing against the standards that they're expected to perform against. The challenge is that then creates difficulty when the change that needs to take place requires cross-functional buy-in and cross-functional collaboration, not only within a business, but in this case, in many cases, across the supply chain. And so, the sustainability team within an organization might set the agenda, but often the responsibility of enacting that agenda lies elsewhere. And so, navigating those silos, breaking those silos, and bringing a set of performance metrics that enable the organization to collectively move toward the future state that's been set forth is really important. And understanding how to cascade those guideposts, those KPIs appropriately down throughout the entirety of the organization, from the top level, or the top floor down to the plant floor. And then more specifically, the visibility to where the most impactful change lies is a key challenge. And this is linked, of course, to the data collection and measurement point that I made earlier.
Mhm.
But the ability to quantify the impact of the different levers that are available to the organization is a key challenge. I think there has been a lot of discussion about the ROI of sustainable manufacturing initiatives,
Yeah.
and sometimes that ROI is unclear. I think that is changing. I think especially in recent years, that's changing, and we're seeing there's more acceptance that the ROI is positive, but there's often difficulty in showing it. And again, the link there to being able to quantify, to collect the data needed to feed those metrics, but then to give them the visibility to the right people who have agency and have the ability to affect the trajectory of the organization against those metrics, I think is a key challenge.
Okay, so that's interesting. In a lot of these discussions, I always like to try and bring in, because we're so focused on technology all the time, I like to bring in the people aspect. And so what you seem to be saying is that a lot of the time, these challenges are actually as much to do with the people involved as they are to do with the data itself. Is that fair?
Certainly is fair. Yeah, I think certainly so. Yeah, and again, I just reiterate that many sustainability is a very broad topic, and so there are elements of any organization's sustainability strategy that will apply to some parts of the organization and not be relevant to other parts of the organization. So acknowledging that complexity is important, but for the subset of metrics that do relate to the plant floor and are influenced by the activities on the plant floor, and I think we'll get to this a bit later in the conversation.
Yeah,
it's really important to align the different people, the different the different roles and responsibilities across an organization, because in many cases these aren't metrics that can be driven by the operations organization alone, or the sustainability organization alone, or the finance organization alone. And so
right.
that kind of cross-organizational alignment and visibility to a common set of guideposts is key.
Okay. All right. So before we get into the digital twin specifically, I just wanted to give Corbus and Alan a chance to maybe give their perspective on the challenges. Guys, do you have anything to add to what Ben said there about the challenges specifically the manufacturers are facing?
Hamish, I would just say I think it is a mounting multi-dimensional challenges coming from many sides, legislation, and it is different in different parts of the world. But I mean, the fact is there are challenges and, mounting challenges. So it is an area where I would say manufacturers and industry can't be complacent.
Right. No, absolutely. I think, as you're right to point out that not only is are the issues and the importance of the issues increasing, all the regulation around it as well is just introducing another layer of complexity, which we all need to deal with. All right. So let's get into the digital twin aspect then specifically. Corbus, maybe you can explain a little bit about what a digital twin is, what it looks like in the context of sustainable resource management. And what are some of the ways that digital twin can help address some of the challenges that we've just outlined?
Hamish, if you look at the sort of common definitions of the digital twin out there that's generally accepted, you can think of it as a digital representation of a physical thing. And so in the context of sustainable resource management, I would refer to it as a software solution that industry or manufacturing companies can layer on top of their sort of existing, let's say, IT/OT systems that can really monitor. It can map onto the existing, let's say, sensor automation infrastructure you have, and it can monitor and model and sort of analyze the usage patterns for, let's say, utilities, energy, water, resources, and sort of start to learn those usage patterns, and really helps you to identify inefficiencies, opportunities for improvement, and really provide your teams, your operational teams through the organization with the necessary tools then to continuously optimize and improve your utilities consumption. So that's on a high level how I would sort of define it. But I think what's very important is that such digital twin solutions, that it has the ability to really meet industry and meet manufacturing customers where they are at. Because, manufacturers, industrial companies may be at various stages of their, let's say, automation journey, of their analytics adoption journey, of their data infrastructure journey. So it's really important that that it's not a big bang and that it really meets you where you are at. But when you get it right, when you implement those solutions correctly, then in doing so, for example, you might be a company who maybe only have some metering around usage, maybe of energy, water, fuels. And then that solution should be able to say, okay, if you only have metering, I can give you some value. Others might have more available data. Let's say they also have production context data. And that solution should be able to then, just adopt that and give you another sort of more value. And others may say, I have a lot of other sensors data. And in such a case, that digital twin should be able to map onto that and, give you sort of even extended. And maybe others may be quite advanced and say, look, I'm willing to allow such a solution to close the loop and take some autonomous adjustments, control actions to automate some, turn things off, slow things down to reduce usage when it makes sense. So I think, a few comments I've made here. It's a digital representation of a physical thing. I would say it's software solutions that layers on top of what you have, that monitors, models it, start to identify patterns and provide you with the tools to continuously improve utilization, but it meets you where you're at. It's not a big bang or a rip and replace kind of thing.
Okay. You mentioned water there. I don't know, Alan, do you have any examples of how this kind of solution can be useful in terms of managing water resources?
I do. I think one of the things that I'd like to do though is connect a couple of dots. And so when Ben was talking, he was really leaning into the challenges that manufacturers have in an ever complex ecosystem of carbon credit, energy use, water use, utilities and resources and things. And then Cobus is bringing in the idea that they can meet you where you're at through a soft sensor or through a digital twin. Water usage, depending on where you're at. And so Gray Matter, this company probably many have not heard of, but we work with some of the largest companies in the world. One of them is a consumer packaged goods company, operates in Europe, operates in Indonesia and the US. And the water requirements that they have vary from none to extraordinarily tight. And what they have to do is make sure that they're producing the same quality of product in every area. And so what they ultimately have to understand is how do they make the product at the tightest constraints that they possibly have, so that they can get replication of that. So that's where a digital twin plays into this. So when you look at how do we make a product with less water or better use of water, or some cases less discharge of water, depending on the complexities of their environment and situation of where that facility is, that's what digital twin really leans into. And that's what you really should be thinking about is how do we make our product perfectly with reduced waste and able to do that in a repeatable way across a number of facilities. And obviously there's a lot of nuanced conversation that happens at each place to get it tuned in. But that's the promise of a digital twin, is that we understand what does that perfect batch look like. And quite honestly, what AI gives us on top of a digital twin or in partnership with that is the ability to monitor at a rate far faster than we ever have before, to make decisions in ways that we never have been able to before. And that's ultimately how you solve through some of these really tough circularity challenges on reducing waste.
Okay, perfect. So yeah, that makes it a lot more tangible, I think. Okay, great. So let's move on now to talk about get more kind of into the weeds a little bit. And Ben, I know you wanna speak a little bit about how operations teams can set kind of actionable goals in terms of sustainable resource management in the context of the production workforce in particular. So maybe you can tell us a bit about that.
Yeah, I think, if we look at COP28 ongoing right now, I think as we think about major themes in sustainability, especially in the industrial and manufacturing space, there's undeniably action is one of the foremost themes. And so many companies, even, before the legislative landscape started to converge and started to solidify, many companies have been recognizing the need to take action and to steer their own ship with respect to their environmental impact, their sustainability performance. And while many of these companies have and continue to publicly commit to goals and set kind of visions for what 2030 looks like, 2040, 2050 looks like, the path to action to deliver those goals is often unclear. And we've said it already on so far in this discussion, that there are emerging and solidifying regulatory standards with respect to assessing and measuring performance against a template or a set of measures that can provide a common framework to evaluate your organization, both within or rather against your journey to 2030 to 2040 to 2050 and so on, but also with respect to your organization's performance against its peers or against its competitors. And in order to drive to action, that standard set of KPIs needs to be cascaded throughout the organization. And the performance management routines that are currently being used these new metrics must be embedded within those. Over the decades, manufacturers have become world-class when it comes to driving lean manufacturing, when it comes to managing quality, managing throughput, yield, OEE. Manufacturers truly are world-class at managing these very complex KPIs within their organizations. And so those same skills and that same expertise can be leveraged and tapped to drive sustainability excellence within their organizations. But what's needed is the link between how those routines, how the activities that are occurring on the plant floor influence this new set of standards. And this is where I think software can play a key role, because software can enable a manufacturing team to understand the relationship between a bunch of complex variables. And now that those capabilities can be extended to include sustainability variables as well. We can talk about the natural gas consumption and its impact on your Scope 1 emissions. We can talk about how you are consuming electricity in running your equipment, the various set points that optimize or sub-optimize how your processes are consuming electricity, and relate that to the impact that it has on your Scope 2 emissions or your water footprint in how that resource is being used in running your factory. So, in terms of driving to action, what's needed is the understanding and the linkage between the events that are happening on the plant floor, the context with which organizations are managing in each day, each shift, each hour, with its impact on not only the set of metrics that they have been measuring themselves against, but in addition, a new set of metrics that are increasingly becoming regulatory requirements, whether in Europe or elsewhere in the world. So my guidance is to really invest in the capabilities that'll enable your teams to see how their actions can affect or do affect rather the different KPIs that are now being used to assess the performance of the organization. And giving that, again, to kind of echo a point that I made earlier, giving that to the people who are in a position to take action and influence whether the organization is on track or off track with respect to the entirety of that set of KPIs.
Okay, and yeah, so I mean, I think, and a big piece of what you're talking about there is integration, and I think, Corbus, you want to talk a little bit about what really becomes possible once you're able to integrate the digital twin in terms of resource management with other enterprise systems. What are the opportunities and possibilities that open up there?
Absolutely. So I think I'll kind of bring it back to something that Alan mentioned. I think once you do that, you now have the ability to jointly start to optimize your operations for production, throughput, yield, but also quality of product, as well as efficiency, including utilities consumption and raw material consumption efficiency, because how you consume energy, water, fuel, raw materials, emit CO2 is tightly coupled with how you run your operations, that affects how you produce product, which affects your product cost. So these are all interrelated. So, I mean, I always use this example. The simplest way to use less is to switch off the factory. But that's not an option, right? So it's really a tight coupling. And so when you start to integrate such a solution with various enterprise systems, I'm going to look at it briefly from the input data that you integrate into such a solution. I mentioned, and firstly, you want to bring in your energy consumption metering. That will tell you how much you are consuming. But you also want to next bring in your production context. So what products are you making, when, on which lines, in which modes is the factory, which teams are on shift, all the various production context data, typically ERP or MES systems. That will bring all of that in context of what's happening. But that might tell you, that will help. Then a digital twin can start to tell you through learning from the past, it can tell you things like, what is the normal expected usage when you're making this product on that line? And so when you're using more than that, suddenly you can it can say, hey, you're using more. Or you can say, when I'm making this product on that line, there's a huge variation in my consumption. There must be opportunity there. So in other words, you can start to know, am I using too much? But you still don't know why. So then if you bring in all your other sensor data, let's say typically from historians, you can start to answer the question through AI and analytics, why? So if you're using too much, why are you using too much? But that's still not fixing it, right? So if you're willing to actually then, close the loop back, for example, to your control systems, where you are confident, you can start to take actions, maybe automatically, autonomously, where it's safe and you have high confidence, like turning things down, switching things off, running things at a different time. And then typically out of the system, if you look at what data it can produce, you can now, for example, use the information coming from such digital twin to feed your production and maintenance scheduling software. In other words, to more intelligently decide when is it best to schedule production or maintenance for, maybe based on energy prices, on where you make things more efficiently. And then the last point I'll make on this is that really allows you to set more realistic goals, because you know where you are at and why, you know where the opportunities are, and you know what's realistic to aim for next. But not only set the goals, but equip and enable your operational teams all the way down to the shop floor to take the actions to make those goals real. So that's what I would say.
Perfect. Right. And that ties it back to the goal setting that we were talking about before. All right. So what I want to do now is to coin a phrase, get real. And I know our audience especially loves real world examples, customer case studies, all these kind of things. So I want to ask each of you about that. And I want to maybe come back to Alan to answer this first. So Alan, can you give me some examples in your experience of how, real world, how this actually works and the kind of results it brings?
Absolutely, and I'm going to continue to build off of the great points that Cobus is making.
Mm-hmm.
So I was recently, if you think about tip of the spear of difficulty, you're talking about the mining cement industry, and one major cement manufacturer out of Europe owns a number of assets here in the U.S. where I'm at. I was with them last week. Cement is a fractional cent profitability business of tons and tons of products. Folks often see it as concrete. That's actually cement is a part of that. You add cement, aggregate, and some other things together, you'll get concrete. So they're essentially taking limestone, mixing it with other things, and making that into their product. Now, what's interesting about that is it is a mass flow that is a mass flow equation that's very, very difficult. So you're dealing with hundreds of degrees of heat, often 700-800 degrees as they burn their product on very long pieces of equipment that have rotating mass and bearings and things. And so it's not very hard to see when you look at a cement facility that you've got an incredible amount of energy and challenges around pollution from the mining of that product. Then you have an incredible amount of challenges around producing the energy for that product, then actually making the product and understanding that. And so what really needs to happen, this is where this industry is going. And again, these are folks that are dealing in fractional sense of profitability, is they want to know, what is the product going to look like in 2 hours? What is it going to look like in 3 hours? Can we begin to predict that quality and make changes now in our processes that improve the profitability of this? And that's one of the things that a digital twin does, is it says, if you continue down the road of all of the ways you're making this is what the product will look like in 4 hours. I'm going to predict the future. If we adjust this one variable, this is what it will look like. And that's how you begin to trim these things in a real world way, is you tie that into a control system that in instance can say, if we turn the burners down just a hair for this series, because we can control very tightly to this heat, and we know that this heat's going to give us this amount of powder at the end, then the mass flow of that goes all the way back to the ship or the vessel. In their case, it's bringing the coal in, and you need less ships to bring coal in, and the entire thing kind of waterfalls out of that in a mass flow. So that's how you kind of land the plane around this, is that minute second decisions and based off of the future prediction, fractional cent businesses make more money.
Perfect. Great example. Thank you, Alan. Cobus, you got another example for us?
Yeah, I will name two. So firstly, we worked with a customer where we were able to combine their production context, so what products they are making, when, on which machines, which lines, with their utilities consumption, energy, mostly electricity energy consumption data. And what suddenly became super real is that it turns out there were a huge variation of how much utilities they were consuming when they're making exactly the same product on exactly the same machine. And so immediately when you see that, but also you could see best demonstrated performance. You could see on that machine, it is possible to consume less, to consume at a certain level. So best demonstrated performance was clear, but last variation. That points to opportunity for improvement. And then, but then they also gave us all their historian data, so all other sensor data around that part of the plant. And by being able to combine that into the digital twin and then apply machine learning, AI analytics against it, it was suddenly became what are the top factors driving the times when they are the variation in consumption when they are making that product on that machine. Exactly pointing, okay, where do you need to focus improvement efforts? And then again, the digital twin would model those relationships, which means you can apply optimizers to it to say, okay, so what is now the most optimal way of making it? And you know, and that is how essentially from the different types of data, the information can pop on not only, okay, where are the opportunities, but why are we using too much and what can we do about it? But what's really interesting is that sometimes when the teams then start to investigate, it comes back to control settings that need to be changed. Maybe a control loop that is not having been tuned correctly. Mm-hmm. And so what is really important is that if you invest in the right type of digital twin solutions, that it provides the tools to address the span of these kinds of industrial problems, all the way from offline analysis to real-time, high-speed, closed-loop control, if possible and necessary, even autonomous, making changes. So that's the first example. The last example is another customer we worked with, specifically in the automotive industry, where specifically the ability to again optimize the controls. They were able to save more than 10%, in fact, closer to 15% of their factory heating energy cost within some of their factory halls. Now, you just think about this. So a lot of manufacturers make things in huge buildings, and a lot of the time in the cold seasons, they have to heat or cool if it's too hot, right? So in this case, they needed to heat, and they were able to, by combining their production schedule data, bringing again that production context in, and bringing in weather data, so weather forecast, and by applying intelligent control to the automatic control systems they have, they were able to more intelligently decide what heating set points to use. So meaning that when it's out of shift hours, they're not producing, they could lower. But they need to say exactly how much to lower, because they know when they need to be back on temperature again, when the next shift is going to start. So how much can they lower it? And when do they need to start to reheat again to be precisely back on the right temperature for the next shift? And in that way, by implementing the control optimization side of these types of digital twins, and by being able to model the way the factory heats and cools in relation to weather forecasts and outs, they were able to gain those significant amount of savings. So those would be my two examples. Thank you.
Yeah, perfect. I mean, that is a sizable chunk of cost, probably for these big installations. Okay, thank you, Ben. One more example from you.
Yeah, sure. I think both Alan and Cobus have made excellent points in really illustrating how you can optimize, within and across a factory. What I would like to do is reiterate a point that Cobus made earlier, which is, leveraging digital twins and analytics to understand the benchmarked performance of a unique combination of production events. So just to give an example, understanding what the expected performance of SKU A is on production line 1 in your Berlin factory, for example. And then not only can you direct your continuous improvement teams to, most effectively use their time, their bandwidth, their resources. I think Cobus gave some excellent examples of that. But then you can also begin to optimize across the system, across the supply system. So you can say, if SKU A performs best on line 1 in Berlin, or it performs significantly better than it performs on line 2 in your Boston factory, you can use that data as an input to your production planning process. And you can begin to optimize across the system and factor that information into to your production planning process. You can make both plant floor optimizations, but also systems level optimizations. And it's really important to stress here that you are able to move beyond simply the optimization of resources, but actually correlate that benefit, that improvement, or that change to its impact on the water stewardship goal that you've set, to the operational carbon, whether that's scope 1 or scope 2 emissions. You can begin to measure the impact of decisions on a wider set of KPIs. So Alan mentioned cost. This is a huge opportunity, because in many cases there are examples such as the optimization of the automotive customers' factory heating, which not only drive lower consumption of natural gas, lower consumption of energy, which has an impact on that customer's operational carbon emissions, but generates significant cost savings as well. And by correlating the optimizations and their impact across cost, across resource utilization, across scope 1, scope 2 carbon, what you can do is you can now begin to factor that into larger, more holistic decision making. And we've got examples in which, or we can talk about examples in which, you may make the decision that produces more emissions because in this particular time period, you have to prioritize a different set of metrics. And so what it does is it enables you to balance the priorities that exist, and more clearly see where there are trade-offs, where there are synergies, where you can make a decision that benefits your financial performance as well as your sustainability performance. But also, you can go into those decisions with eyes wide open and understand what it is that you're doing in making the decisions that you are. So there may be perfectly reasonable decisions that you have to make that increase the scope 2 emissions for that particular shift, but you had to do it because you had to prioritize another set of priorities. So providing the linkages between the resource consumption and the actual impact they have on these organizational KPIs enables you to see those trade-offs, to see those synergies, and to make decisions again with eyes wide open.
Okay, perfect. So I want to make sure we have some time for some questions, but there's one more thing that I want to cover before we go into that, and it also, I hope, answers a question that came in from Jesus Acosta, which is basically around, okay, so we realize some of these opportunities where we don't have it in place yet. So where should manufacturers really start when they want to build and deploy this kind of digital twin in a resource management context? So again, I'd like to just go around the table. I'll start with you, Alan, if that's okay. What are the first steps from your perspective?
So the first step is data preparedness. And so one of the things that you really need to understand is what are we trying to accomplish, and have a clear vision of that goal. And then the second part is there's a lot of getting the data aligned, making sure you have it. Cobus has spoken a number of times on having the right sensors, but ultimately clean data gets better results. And there's a lot of work to doing that. When some of our food and beverage customers that we work with, that's one of the things that we really dive into is how do you get all of your machines, all of the inputs onto the same time slices? How do you understand what that data looks like? Are there issues inside of that data? And then ultimately you can begin to derive very simple things from that and then begin to build that twin. So it's more of a journey than folks want to admit. Sometimes it's not often a very quick destination to get to, and it involves a number of steps, but the very first one is making sure you've got a clear path to good data.
Okay, brilliant. Thank you, Alan. Ben, what are your thoughts on what else manufacturers need to do to get started down this road on digital twin building?
I would recommend evaluating the ability of current systems, the abilities of existing systems, rather than manufacturers getting bombarded with different solutions and new tools and things like this all the time. And so my guidance would be, look to leverage what is already installed. Look to extend what you can with what's already installed and implemented in your across your operations. The need to move quickly is paramount here, especially with just to give a European example, the first CSRD compliant reports are expected in January of 2025. So it's important to be thinking, how do we move quickly? How do we do so in the most cost-effective manner? But also, back to the change management point that we've made, it's understanding how to extend existing systems enables you to avoid the retraining and the project management constraints or challenges that come when you're introducing a brand new tool. So if you can look for ways to extend existing systems to a new application, to a new set of data, again, Alan's point is really good. That data has to be clean. It has to be high quality. But the extension of existing systems to new use cases enables you to offset some of the change management challenges that these kinds of demands present.
Okay, great. So we've got data quality and preparedness. We've got speed. Corbus, what do you want to add to that in terms of first steps for manufacturers?
Well, I would say the good news for industry manufacturers that the solutions that we have discussed here today exist. They are ready from globally trusted vendors that's ready to help our customers. So, my message would be, if you haven't already implemented something like this, then start as soon as possible, because time is ticking, basically. Pressures are mounting. But I would absolutely echo what Ben has said, right? Look for a solution that easily layers on top of your existing set of whatever OT systems you have, landscape of automation landscape you have. Don't think big bang, think a journey. Don't try to rip and replace, but there are solutions that easily integrate with, layer on top to help you and provide you with the tools to really make rapid and quantifiable progress on your sustainability goals. That would be my guidance.
All right, perfect. Thank you very much. That gives us a perfect 10 minutes now to rattle through some questions. And I guess the first one is for the GE representatives in the room. This is from, and I apologize to everyone in the audience, everyone who's asked a question in my potentially dodgy pronunciation of some of these names, but I will do my best. So the first one, as I said, is about GE. It comes from Mohammed Hanafi, and he asks, what is the difference between GE APM and the digital twin? And what are the applications and verticals that are relevant for each of those?
Maybe I will take that one.
Yeah.
So essentially, GE. So as you might know, GE has basically very recently is in the process of becoming 3 GE businesses: Vernova, Aerospace, and Healthcare. Ben and I are from the GE Vernova business, which is focused about really helping the globe provide the energy it needs to transition with sustainable energy. And within the Vernova businesses, we are part of the GE Digital business, who's really for many decades been providing industry with industrial software. And specifically within the digital business, we look at power generation, oil and gas. So we basically help customers make, distribute, and consume energy. So on the generation side, we have a power generation, oil and gas business who really serves that part of the sort of those industry segments, power gen, oil and gas, with software to help them optimize the generation side of things. Then we have a grid software business that really serves distribution, optimize the distribution of electricity grid. It's becoming ever more difficult to manage because of all the renewables. And then we are part specifically of the manufacturing business that really helps industry and manufacturers optimize their operations with industrial, how to run their factories better, basically optimally, and also on the demand side, consuming. So so that is the GE context that we are from, and that is essentially how GE also so the APM, GE has in these businesses a variety of software products, and our asset performance management product is part of our oil and gas and power generation business, and it's specifically focused on high industries like power gen, oil and gas with super high value equipment like gas turbines or and so where the replacement value of those pieces of equipment is huge, and it's sort of rotary equipment often. So when you're looking at high value assets, our APM products apply, and it's very well industry leading for that. But then in the manufacturing space, you have it's kind of the manufacturing sector has slightly different requirements, and there GE has a different set of especially our prophecy products, which are very suitable for helping customers optimize how they run their manufacturing plants, including sustainability.
Okay, good. Thank you for that explanation. We have now a question from Sajid Chowdhury. I hope I'm going to get the gist of this correct. So they're saying IIoT, UNS, manufacturing analytics, kind of as, the traditional style, I guess, is still getting implemented. And so in that scenario, has digital twin, arrived ahead of its time, without the building blocks being in place for it to, for it to really be useful? Or so is it too early, or is everything mature enough that you can really build an incredibly useful digital twin right now? I know you mentioned, Corbus, before that you were saying these tools are available, but is it realistic to really start using them their full potential now, or is that still a bit further down the road?
I'll just simply state I don't think we're too early. I think we have within GE Digital, we have plenty of examples in which customers are deriving real, tangible, multi-dimensional business value from leveraging their automation systems, their MES systems in concert with digital twins and analytics tools to generate concrete business value. So no, I don't think it's too early. We have, as I said, plenty of examples in which customers are doing that today.
Well, I think it goes back to, it's been a decade since GE really introduced the digital twin, and for Corbus, it's been almost 2 decades that he's been working in this piece of science. I think what's changing and why it's becoming more of a discussion is the cost points of the Internet of Things, allowing us to measure things that we couldn't measure before, which makes it more valuable. The science is now proven, and the computing power to pull it all off is now available. So when we think about the progression, if you go through the curve, we've gone through the trough of disillusionment. We're coming out on the other side, and we've got the computing power and the science are now meeting up along with the cost equation to make it work with all of the variables that we need. So I don't think it's too early. I think it's actually developing quite nicely, and we're beginning to see a massive uptick in folks thinking, are we going to continue down the path that we were on, or do we want to jump a generation? And I think that's what's going to happen, is these are going to merge very quickly over the next 24, 36 months. and it's going to be a nullified conversation.
Okay, Corbus, I guess you would kind of agree on that front.
Absolutely. I well said. I have nothing to add there.
All right, so I got time for one or two more. From Ricardo Silva, what are the benefits of digital twins compared to real-time monitoring systems? Are there additional benefits to be had from a digital twin?
So I'll be very brief on this one. Real-time monitoring is fantastic, but it's just that. It's real-time monitoring. What you really want to do is leverage the digital twin into real-time action and being able to predict what that action is going to do minutes, hours into the future. And that's ultimately the difference. And so changing things because of how they are today or this moment is the one thing, but changing things how they are right now because of what they're going to result in the future is the difference.
Okay.
Well said, Alan.
Ben, Corbus, anything to add on that one?
No.
I think
Thank
Alan
you.
said it well. Yeah.
Okay, good. All right, I don't know if this is going to get too into the weeds in terms of the technology, but I'll give it a shot anyway. So Giancarlo Caletta asks, what do you think about emulate 3D software as a digital twin tool? Is that something you can comment on, or is it too?
No, I think that sounds like he's asking about a very specific product, which I can't really comment on. But
Okay.
Again, just maybe saying something in general. I mean, again, what is a digital twin? It's a digital representation of a physical thing. So in that sense, any model, so come back to the question about real-time monitoring versus a digital twin. I mean, if I put a sensor value on a screen, I can say I'm doing real-time monitoring if it's updated in real time. But what does that help me? I know what the value is. So next thing you can put an alert on it to tell me something is wrong. To Alan's point, what does that help me? It's really when you go analyze, monitor, predict, or forecast, and then maybe when you then create a model, a behavioral model based on history and other factors that based on AI, ML, if you have data, or based on physics, which explains the behavior of the asset. And that can be mathematical, but also it can be a 3D visual design model. So a digital twin can have various facets to it, including 3D visual design models. Now you can start to predict, you can start to simulate, you can do what if this changed, what will be the effect? And then you can turn around and start say, what do I need to do now to have the best result in 3 hours, to Alan's point. Thank you. Okay,
so yeah, I think the conclusion is that ongoing actionability is really the core of the value from the whole digital twins concept in this space. All right, guys, we're out of time. Thank you very much for your expert insight and knowledge. Thank you to the sponsors, GE Digital. The events like this are not possible without you, so thank you. And thank you, of course, to our attendees for your great questions and for your attention. The next session is AI-powered quality control in manufacturing, leveraging IIoT for zero defects, sponsored by Trackonomy. So enjoy the rest of the event, and I will no doubt see you at the next one. Thank you, and have a great day.
Thank you.